Okay, this video is going to help you understand how to map genes into different linkage groups. So this is number 8 from the Mendelian genetics problem set. Okay, so here is a series of 2-point crosses carried out among 7 different genes, and this produces the following recombination frequencies. Remember from class that recombination frequencies equates to map units or distances between genes. Also remember that a 50% recombination rate between 2 different genes means one of 2 things. They're either very far apart on the same chromosome or they're on different chromosomes. So here the goal of this problem is not to map out the genes onto different chromosomes, it's to map them into different linkage groups. Okay, so first we're going to look at that first pair, A and B. They have a 50% recombination rate, so that means they are in different linkage groups. So I'm going to draw one linkage group here and put A in the middle, and another linkage group here and put B in the middle. They are in different linkage groups. Now they could be in the same chromosome, only very far apart, but we are not drawing chromosomes. Again, we are drawing linkage groups. Okay, so now look at A and C. A and C also are in different linkage groups, so it could be together with B or in its own linkage group. So let's look at B and C, which is down here, B and C. B and C's recombination frequency is 10%. So that means they are in the same linkage group, and B is someplace close to C over here, and they are 10 map units apart. Okay. So now look at A and D. A and D is a 12% recombination rate, so I'm going to put D over here, 12 map units apart. A and E are 50% recombination rate, so again, they are in different linkage groups. Is E also with the same linkage group as B or C? So let's look at B and E. Yes, it is 18 map units apart. So let's put it over here for now. 18 map units apart. A and F are in different linkage groups. So let's look at F in relation to B. B and F are also in different linkage groups. So that means we have a third linkage group here in which F appears here. A and G are 4 map units apart. So let's put it over here for now. 4 map units. B and D are 50%, so they are in different linkage groups, and that checks out. B and E are 18 map units apart. We already did that one. B and F are in different linkage groups. That checks out. B and G are in different linkage groups. That also checks out. C and D, different linkage groups. C and E are 26 map units apart. Okay, so if you look at C and E, the way that we position them in this linkage group, they equal about 28 map units apart as opposed to 26. So let's star that for now, and I'll come back and explain why there might be a small discrepancy there. Any large discrepancy between 2 genes, maybe you put them in the wrong order, but any small discrepancy that, we're going to come back to that at the end of the problem. So C and F are in different linkage groups. Yes, that checks out. C and G are in different linkage groups. Yes. D and E are in different ones. Yes. D and F. D and F, yes. D and G are 8 map units apart. Okay, so let's look at D and G. The way I've positioned them here, D and G add up to 16 map units apart. That's much different from 8 map units apart. So what that means is I've put G in the wrong place. So now let's cross this out and put G over here. Remember, A and G are 4 map units apart. A and D are still 12 map units apart here. Now D and G are 8 map units apart because 12 minus 4 is 8. Okay, so you have to sometimes, when you first place something, you have to correct your mistake and reposition it so that it makes sense based on the recombination rates of the other genes. E and F are in different linkage groups, yes. E and G, yes. F and G. Okay. So far everything pretty much checks out except for this one here, C and E, where there's 26 map units apart, which is the percent recombination rate, and we've mapped them out to be about 28 map units apart. So 26 or 28 is actually a fair amount of distance, so the likelihood that you're going to get a double crossover event happening between E and C is actually pretty high, and sometimes double crossover events can give you discrepancies in the map unit distance and also the percent recombination rate. So it can give you a little bit of 1 map unit off in distance or 2 map units off in distance. So if you ever see something like that where there's a discrepancy, or moving these genes around doesn't solve the problem. In fact, if you were to move E over here, that would make the problem worse, and it wouldn't add up even more so. Then you can assume a double crossover event likely occurred between those two different genes. Okay, so I've mapped all of my genes. I have 3 different linkage groups, and make sure when you label the distance between different genes, you also put the unit, which is map units. Okay, that's all. Good luck.